What do you do when you have a lot of projects to choose from and you want to make as an objective decision as possible? With just a few projects and just a few criteria, it isn't that difficult. But when you have dozens of projects and multiple criteria, it becomes extremely difficult. And that's where Optsee can help. In this video, I'll explain how Optsee easily quantifies decision criteria and then combines them to obtain an objective value score ranking based on your preferences. We will start by using a simple car buying decision as an example. When you are making a purchasing decision, you are comparing many different buying criteria such as price, appearance, gas mileage, and brand, so buying a car is a multi-criteria or multi-attribute decision. The criteria or attributes that you use can be used to compare different cars no matter if the car is a fast, expensive race car, a large minivan, an SUV, or an economical compact. However, because different car buyers will have different buying goals, they will rank the importance of these attributes differently. So gas mileage might be the most important attribute to one buyer, and engine horsepower might be the most important to another. The key thing to remember here is that cars as a group have a common set of attributes associated with them, but individual cars have different values for those attributes. For example, every car has a cost attribute associated with it, but the individual cost for each car is different. So your attribute attractiveness can be expressed as value points and displayed graphically. In this chart, the attribute values are plotted on the horizontal or x-axis, and the corresponding value point score is plotted on the vertical or y-axis. The left side of the chart shows that cars that get less than 10 miles per gallon have no attractiveness or 0 value points. On the other end of the x-axis, cars that get 50 miles per gallon are the most attractive with 100 value points. Most cars would have gas mileage ratings between 10 and 50 miles per gallon and would have value point scores between 0 and 100. Here is another example. This one is for the attribute called cost. In this case, cars priced at $60,000 or more earn no value points for cost, and cars priced at $20,000 or less earn 100 value points for cost. Of course, there are cars that cost more than $60,000 and there are cars that cost less than $20,000. But this chart reflects this buyer's preference that cars costing more than $60,000 and cars costing less than $20,000 will not be considered. Spending $20,000 would be this buyer's best outcome, and spending $60,000 would be this buyer's worst outcome. Most cars this buyer would consider would cost between $20,000 and $60,000 and would have value scores between 0 and 100. When you're comparing cars, you consider only cars somewhere between your attribute limitations, that is, between your best and worst outcomes. The car in these charts has a cost of $24,000 and gets 22 miles per gallon. Since a cost of $24,000 corresponds to an attractiveness value of 90, and 22 miles per gallon corresponds to an attractiveness value of 30, the unweighted combined overall attractiveness score for this car is 120. However, scoring attractiveness in this way assumes that both attributes are equally important. In most cases, this isn't true. So how do we show buyer preferences? We can express preferences in our model by weighting the attributes. For example, we can weight the gas mileage attribute at 100, and we can weight the cost attribute at 200, meaning that the cost of the car is twice as important and has twice the influence in our decision as the gas mileage. When we factor in the weights, the value score is 70. Now it's important to remember that Optsee performs all this math for you automatically. The attribute charts are created by pointing and clicking, and all the data entry is done through forms, as you'll see in just a few moments. The math that Optsee uses is a bit more complex than this example, but the underlying logic is the same. The weighted overall value score, therefore, becomes the basis for objectively comparing and ranking your different projects based on your selected attributes and the relative weights that you have assigned to those attributes. In this simple example, using only 2 weighted attributes, you can see how Optsee would rank the cars based only on price and gas mileage. You can see that it ranked them in the same way that you would if you did it manually, that is, ranking first by cost and then by gas mileage. However, most business investment decisions involve many more choices and many more attributes. Optsee makes it easy to compare and rank virtually an unlimited number of choices using up to 60 different attributes. Plus, as you will see, you can use many different curve types besides just straight lines. Optsee bubble charts are another useful way to see the relationships between different attribute values and value scores. Here you can quickly see that the car with the highest value points also had the highest gas mileage and the lowest cost, and the car with the lowest value points had the highest cost but was in the middle range for gas mileage. You can also see how the other cars were ranked relative to gas mileage and cost. An important thing to remember is that Optsee is meant to support your decision-making process and not make the decision for you. So it is often useful to start with a small set of projects that you have ranked and use them to develop your attributes and relative weighting model. Now that you've seen the fundamental concepts of ranking choices using Optsee, you can see that you can do the same thing with business investment choices and projects. For example, you can use attributes such as cost, net present value, human resource requirements, market impact, risks and probabilities, anything that you can think of that's important to your business. Now, let's take a look at some of the forms Optsee uses to manage this data. In Optsee, business attributes including costs, returns, and risks are listed in decision model forms and used as the objective basis for comparing projects with each other. You can have up to 60 different customized attributes, but most projects can be ranked on the basis of 7 to 10 attributes. Attributes are easily entered and edited using the attribute form. You can easily choose from many different curve types such as linear, step, and S-curves. You can also use categorical data such as high, medium, low, or excellent, good, fair, and poor, whatever you want. With Optsee, you fit your model to the data. You don't have to force the data to fit your model. You can save each project's data in a customized business case summary, and you can set individual baselines and use color indicators to track against project changes. And with Optsee, you aren't forced to use just single point values. You can enter ranges such as 40 plus or minus 10%, so your data reflects real-world uncertainty. You monitor your project portfolios in a form that displays a ranked summary of each project's business case. The colored spheres tell you which projects have changed from the baseline. Red indicates a major change and yellow indicates a minor change. The columns on the left let you track each project's current status, such as whether it has been approved, rejected, or forced in as a mandatory must-do project. To summarize, we've seen how you can break business investment decisions into attributes and how you can model them graphically. We've also seen how you can easily weight and combine your attributes using Optsee to make an objective and systematic comparison of your projects based on your preferences. Finally, we've shown you how you can use categorical attributes in your project portfolios. In all these ways and more, Optsee lets you build your model to fit your data, not force you to fit your data to a predetermined model. If you have any questions, please feel free to contact us. You can sign up for a free trial to try Optsee with your own data at www.datamachines.com. I'm George Hune, President of Data Machines, and thanks for watching.